On the eastern side of Florida, there's a small piece of land known as Cape Canaveral. If you're from the United States or maybe follow rocket launches, you'll know this coastal Floridian city as the launch pad for space exploration, literally, including launches of the first American astronaut, lunar landing, and 65 years ago, the first weather satellite. On April 1st, 1960, NASA launched its first weather satellite, called the Television and Infrared Observation Satellite 1. And because science loves initialisms and acronyms, this satellite is better known as TIROS-1. TIROS-1 sent back some of the first images of Earth from a bird's eye view, and more importantly, was a new age of weather data and weather prediction. Fast forwarding to the 1970s, the US government creates NOAA, the National Oceanic Atmospheric Administration. And this new federal organization, fresh off the heels of the space race, begins testing a new type of satellite. See, in the 1970s, NASA and NOAA were trying to create a satellite that would stay over a fixed point on the Earth, rather than a satellite orbiting around the entire planet. Not only did NASA and NOAA want to see a bird's eye view of Earth, but more importantly, watch clouds and weather patterns form over time. This then new type of satellite is known as a geostationary satellite and would ultimately revolutionize the weather industry. And on June 25th, 2024, if all goes to plan, NASA will launch the final installment in this generation of geostationary weather satellites. GOES-U. GOES is the acronym for all of these stationary satellites launched by NASA. GOES stands for Geostationary Operational Environmental Satellite, with the U indicating the version in the series, and like all of GOES' older siblings, GOES-U will be renamed as GOES-19 once it's properly positioned in orbit. To understand the impact of this generation of over 40 years of weather satellites, we need to first understand what's floating above us. There are two main types of weather satellites: polar orbiters and geostationary satellite. Polar orbiters are satellites that continually circle the Earth from north to south. With each lap around the Earth, polar orbiters stay on the same orbit while the Earth rotates beneath them. So over time, they're able to capture an entire image of the Earth. Polar orbiters are pretty low orbiting satellites, orbiting between 130 to 600 miles above the surface of the Earth, with each orbit taking about 100 minutes. Due to their low orbit, polar orbiters are great for ground observations and, per the European Science Agency, reconnaissance. Basically, polar orbiters are close enough to the ground that they're able to take high-resolution images of the entire Earth. And their not-so-distant cousin is the geostationary satellite. Geostationary satellites are stationary with respect to Earth. Once a geostationary satellite is launched, it will always stay above the same area of the Earth, regardless of whether it's night or day. Unlike a polar orbiter, which uses the Earth's rotation to its advantage to scan the entire planet, geostationary satellites want to match the rotation of the Earth, so they're always focused on the same area. That's to say, the period, or the time it takes to complete one rotation of both the Earth and the geostationary satellite need to be the same, which is on the order of 24 hours. By monitoring the same area of Earth day in and day out, GOES sends back images like these, which you've probably seen if you're ever watching severe weather coverage or hurricane coverage. And you might notice that some of these images are huge, literally taking a picture of almost 25% of the planet. To be able to see a quarter of the Earth, GOES satellites live 22,000 miles above the surface. And that's approximately how high GOES-U will be orbiting once launched on June 25th, 2024. The United States depends on two key geostationary satellites, aptly named GOES-East, GOES-West. And GOES-East and West monitor most of the Western Hemisphere, with GOES-East covering most of the eastern seaboard, Atlantic Basin, Gulf of Mexico, watching for Atlantic hurricane season, with GOES-West covering the western seaboard and Pacific Ocean. Since its inception, the GOES series has morphed into one of the most sophisticated weather monitoring systems on the planet. Its mission objective is to provide continuous weather coverage of the Northern Hemisphere. And in each iteration of GOES, which are launched every couple of years, the satellite gets new technology improvements, making weather data collection faster easier, and more detailed. GOES-U is launching with more modern versions of features its predecessors had, including a higher memory disk to hold more frequent scans of the Earth, lightning imaging, and a new geomagnetic storm tracker. However, the biggest breakthrough on GOES-U is the camera, known as the Advanced Baseline Imager, or ABI. There are two key feature improvements of the ABI. First is the actual camera. The ABI is an incredibly powerful camera that can take photos in both visible and infrared light. Infrared light waves are just beyond the visible spectrum that us humans can see. Infrared light is really great at measuring one piece of weather data that's incredibly important: heat. Most weather phenomena can be simplified into the interactions between cold air and warm air. Warm air rises, cool air falls, and the mixing of the air, or the temperature differential between the ground and the tops of the clouds, can tell us a lot about what types of weather to expect. In the case of GOES-U and the ABI, if the ABI is reading incredibly cold cloud tops, we can expect more severe weather underneath those clouds. So in the case of GOES-U and the ABI, if the satellite is measuring really cold cloud covers, we expect the storm beneath it to be stronger. And infrared imaging means that we can take photos regardless of whether it's day or night. The second amazing thing about the ABI aboard GOES-U is the camera's resolution. Not only can this camera take a photo of the entire hemisphere in 10 minutes, but the ABI can take rapid photos every 30 seconds of a specific place. As you can see in this video, the ABI switches between scanning huge swaths of Earth to scanning the US, and then specifically scanning this hurricane off the coast of Mexico. As we see in this video, the hurricane's being scanned every 30 seconds. This type of rapid imaging is also incredibly helpful for tracking squall lines, severe weather, and supercell storms across the Plain States and southeastern United States. This camera means that meteorologists can get scans of these storms every 30 seconds. The ABI's infrared imaging is important to severe weather tracking and heading into this season's Atlantic hurricane season, which is predicted to be particularly active, which is why it's so important for the GOES-U satellite's launch to go well. Once launched, it'll take a week or two for GOES-U to get into geostationary orbit. Then once GOES-U has reached its orbit at about 22,300 miles above the Earth, it'll get rid of its U designation and be renamed as GOES-19. For the first few months and even up to a year, GOES-19 will not yet replace GOES-East. This new geostationary satellite will sit in a temporary position known as on-orbit checkout location. During this time, NASA and NOAA will run validation checks to make sure that no equipment was damaged on launch or positioning, and that the data that GOES-19 is sending down is trustworthy. And if all goes to plan, after GOES-U completes and passes all of its validation checks, it will begin a programmed drift to replace GOES-East or GOES-16. So if this is the last GOES satellite, what's next? First, let me be clear. There'll be no gap in weather data. The current series of GOES is expected to work well into the 2030s, but NASA is already preparing for the next generation, building a series called Geostationary Extended Observations, or GeoXO. The GeoXO series is planned to launch in the early 2030s and is expected to replace the current R series. NASA and NOAA are trying to track patterns to predict the effects of climate change on weather events, and are adding more equipment to the satellites to track not only weather, oceans, and atmosphere, but also pollutants, drought, and flooding. It's amazing how much progress NASA and NOAA have been able to make, not even in the past 65 years, but the past 10 in this current R series of GOES satellites. And on June 25th, 2024, I'll be watching and hopefully celebrating the successful launch of GOES-U. You can watch the launch on nasa.gov. And if you made it to the end of the video, thank you so much for watching it all the way through. I really loved making it, and I hope you enjoyed it too.